continuing with the topic of vectors in 2D. Last time when we were in this topic, we were dealing with the Cartesian plane, calculating the component of x, like x components, y components, calculating resultant force. It was all about calculating the angle and the resultant force and all that, etc. So now, today, we are going to deal about the physical life. We are no longer going to talk about the Cartesian plane, but then now we are going to calculate, the things that are in general life, the objects that are moving, the objects that are doing this and that. Like, we're going to talk about, the objects in general life, what happens, what are the forces that are acting on that object and all that. So now, as you can see before the screen, people, we have an object. This object, I fully believe that everyone understands what's going on there. We have an object which is hanged on a ceiling. So the ceiling and the object are connected using a rope. So now, what are the forces that are going to act on this object? So now, in this object, we're going to find out what are the forces that are acting, and with those forces, we have to draw the vector diagram and the free body diagram. This is how free body diagram looks like, and this is how vector diagram looks like, so don't be confused. But then with this object that is before the screen, we can only draw the free body diagram, but we cannot draw the vector diagram. Sometimes it's called closed vector diagram, but vector diagram, closed vector diagram, whatever you call it. I'm going to first give you the first 3 or 4 objects which we can only draw the free body diagram, where we can't draw the vector. And then as we go on, I'm now going to be giving you the objects which we can now draw the free body diagram and vector diagram. Note something, people. I'm going to say this and hopefully believe that people will put this in their head and never forget. You cannot draw a vector diagram without finding a free body diagram. You have to find free body diagram first before you find the vector diagram. So as I said, in this object, we can only find what? Free body diagram. So now, people, we know in general, like everybody knows this, and we know this in grade 9. We know this in grade 9 that or is it grade 7, that there's something that is called gravity. Each and every object on earth, it is experiencing gravity. Like, for example, if I am holding a cell phone and then I drop it, that object is going down because of gravitational force. Gravitational force is pulling it down. So each and every object, whether it's hanged, whether it's on the table, wherever it is experiencing gravitational force. So now this object, where is it? It is this object that is being hanged on a roof. It is experiencing gravitational force. How are you going to show it? Just like this. You say it's going down, Fg. It's experiencing gravity. Or you can say W, meaning weight. People, note something. There's a difference between a weight and a mass. There's a difference between weight and a mass. As you grow in physics, you will be able to understand there's a difference between weight and a mass. But then we can say weight is a gravitational force. So meaning you can show it by Fg or W. So anyhow, the way you want. Okay, people. So now there's a gravitational force acting on this object that is being hanged. And now, people, can you see? Don't forget, it is pointing down. The arrow is pointing down. If you don't show, it's like you are not showing us what is going on. You must specify, show the arrow. It is going down because of gravity. It's always going down. You will never find gravity going up. And then now we have the rope there. On the rope, there is something that is called tension force. The tension force is there between the ceiling and the object. So now the tension force is going where? Is going up. Is going up. So meaning we are going to say it's going like this. So this is our free body diagram. You are going to say it's going up. So how do you show it? You say Ft, or you can say T, the way you want, just T or Ft. So now meaning a tension force, or you can just say tension. So now there's a tension force. Those are the only two forces acting on our diagram.
You must understand that our tension is going up because our rope, it is connected on the top of the object. If our rope, it was connected on the right hand side of our object, meaning it was going to go to the right, and if our rope was connected on the left hand side of the object, it was going to go to the left, our direction of the tension. And if our rope was connected below the object, which means it was going to go down. But then now on this at this stage, now we can see that our rope, it is connected with the object on the top of the object, meaning our direction of the tension is going up since it's connected on the top. I hopefully believe that's understandable on the tension. Let's do other questions.